Hello everyone, this is the Flame tutorial. Flame is a powerful software to help you design a complicated genetic circuit, and I will explain how to use it in this video. After you open our software, you will see this. This is our main page for you to design. On this page, you can add a circuit or remove a circuit. When you finish the design work, you can click the Complete button to submit your work. A button below is a switch between Design Framework and Truth Table, which I will explain later. And this little arrow here is the material box. So let's get started. If I want to use the BioBricks to build a genetic circuit called the AND gate, like this. First, you open the material box and choose an input. And then our software will recommend the promoter which cooperates with the input you've chosen. If you are not satisfied with our recommendation, you can search for what you need. For example, if I want to find a promoter called PLAC, I just need to search it here and choose it. Moreover, we also recommend receptors. After that, you just need to drag them here to do the second input choice, like this. Then you also need to drag your output to the canvas, like this. At last, it is up to your choice to choose either framework or truth table to connect your inputs and output. If you choose the framework, you just need to drag them here and finish your work. If you choose the truth table, you click this button, switch to truth table, and fill in the contents like this. Click the submit button and choose the AND gate. So here your job is finished. Our software will do the rest. After you finish the design, you can find your result here. We provide 4 kinds of view for you. In the device view, you'll see every single component in your genetic circuit. You can also zoom in or zoom out with the scrolling bar here. We also include the relationship between them. Here you can see the input IPTG and mercury ions. IPTG inhibits the receptor BBA I732100, and the mercury ions inhibits the receptor BBA K346001. And these two receptors inhibit these two promoters respectively, which indicates that the input IPTG activates the promoter BBA R0010 and mercury ions activates the promoter BBA K346002. In the parts view, we arrange components into 3 groups so that you can look at them more clearly. In the vector view, we put these components into a plasmid with restriction enzyme cutting site. Finally, we also provide the DNA sequence for you. With these 4 kinds of view, you can examine your design from 4 different angles. We also provide simulation section based on sophisticated math models and algorithms. Here you can see 2 different curve graphs. One is static performance and the other one is dynamic performance. When you need to know the quantitative relationship between input and output, you choose the first one. And when you need the relationship between time and output, you choose the latter. You can switch between these two graphs. Using this little magnifier, you'll be able to see a bigger graph with more details. You can also make slight modifications inside the graph. If you have designed more than two circuits, you can switch between them by clicking the buttons here. You can also change the RVS among your genetic circuit with the scrolling bar here. Moreover, we prepared an experiment procedure for those who want to do further experiments. There are several steps, and by following these steps, you can make a plasmid containing the genetic circuit you design. Finally, a navigation function is also included in our software. Here you can see our 4 sections in our software: design, display, simulation, and experiment. And if you need any help, you can click on the help button and find out how to contact us. So that's all for the tutorial of the Flame software. I hope you can enjoy it, and I hope that it helps you a lot. Thank you.